Hello friends, welcome back. If you are new, please subscribe and click on bell notification icon. In the last video, we saw property decorators. In this video, we will start input files like reading files and writing files. So how we can do, okay? So before starting the reading and writing files, so first we will see like what is the concept for this. So variable list and classes exist. Classes exist only in your system temporary memory, like RAM, right? So the moment your script finishes executing, your computer powers down, that data vanishes. So when you are doing any operation, anything, you are saving data in the RAM, that will be removed. So to build persistent application, we move data from volatile RAM to the non-volatile disk, okay, like hard disk. So Python abstract file says data streams. When you open a file, Python sets up communication between your program and OS file systems. When we start writing or creating files, so Python start communication between our code and OS file system, allowing us to read and write chunks of data. So we have built-in function open. So function is gatekeeper. It takes file path and mode of characters. So what is the mode we need to use? So and later I will explain what mode we have, like read, write, okay? So those we use with the open. Next we have like real world program. Like we have an old age tape recorder, right? So how that will work? We insert tape. So similarly we have open a file with open. Next we have decide mode, right? We can record or we can read. So similarly we have R for read, this is the mode, and W for write, okay, for recording or overwriting. Next we have play it. So the Python has internal cursor, the file pointer, showing exactly where you are currently reading or writing the file. Similarly we have closing the file with close, so the other program can use, okay. So this is the basics of open and how we read and write file. So before that we will start having some basics related to the. So before we start anything with the writing and reading files, we should know like our current directory details and how we can change directory if we want to. So we will be learning about that. So before opening and saving files, it's vital to knowing where your Python script is currently looking, and this root folder is called the current working directory, CWD. If you open a file using relative path, like open data.txt, we are not giving complete path here. Here we only giving the file name. So Python automatically prefix it with the CWD behind the C. So it will add our current working path before this, okay. Python provides two major libraries to inspect and update the working directory, the traditional OS module and the modern object-oriented Pathlib module, introduced in Python 3.4. Before 3.4, we used OS to save file or change directory. Okay. Check current directory. If we want to check our current directory, we use os.getCWD or path.cwd. Similarly, if we want to change directory, we use os.ch directory and we will give the new path. So we will see this one. Like I will copy this code, okay. So what it will do? So we are importing OS and Pathlib, path from Pathlib. So first we are getting current directory os.getCWD and we are printing current directory using the OS. Next we have changing directories. So we have os.change directory // so it will go to the navigate one level in the up on the folder tree, okay. So what we will get, os.current directory we are calling again here. Next we are using second method called pathlib. So we imported path right here. So path.cwd, like change current directory, current working directory. So it will store pathlib.hyphen directory here and it will print. Next we are having path join much cleaner with the operator instead of string addition, right? So we have subfolder data. So here we are printing the path for this one, target path. We will run this one. So you can see it's printed. You see drive name, username and folder name for current working directory. After that, we move that to the change directory using this one. So to move up in the current directory. So you can see this is in correct. So if you move in the one directory, so it will be here. So you can see it's printing dhak, right? Next, same thing, it is printing the current working directory, so it will print same. After that, you can see we are edited subfolder. Inside subfolder, we have data.txt. So it is showing subfolder and data.txt. So this is how you can check the current working directory and change the directory. So this is some hard coding things like always put the relative path joining using Pathlib instead of hard coding absolute paths. So like if you are running this one, right? So this C username, this will be different in my system. If I run this code in the server or any other places, that will be different, like your colleague machine, Docker container or Linux staging server. So this will be different. So the code will fail, it will not work properly. File operations, we have like we can rename file, remove and copy file. So behind reading and writing data, production application must frequently perform file system maintenance, copying backup templates, renaming temporary locked targets, and deleting the cases. Python splits these takes between three standard libraries: OS, shutil, and Pathlib. So we rename file and folders. We use os.rename or path.rename. If the target names already exist, Python will raise file existing error. Like you already have test.txt. And if you try test.txt, and if you have other file that you will rename the test.txt, then it will throw the file exist error. Same copying with shutil. So we have shutil.copy. So it will take source and destination, copy the file data and its permission. So the destination can be a folder. So if we are copying anything like any file data, so that file has a permission, right? Read, write. So those permission will also copy here. Same we have shutil.copy to, so to copy the data permission and all the metadata like creation, modification, timestamp. So always prepare this for backups. Okay. So deleting and removing, we have os.remove path.unlink. So the delete an empty folder is os.rmdir means remove directory, and path.rmdir then remove directory for this one also. Next we have chunking file size. So what it means, chunking file size? To find out how large a file in bytes, you can either use the classic os path.get size function or the modern object-oriented path.state.str_size attribute. This is extremely useful when checking the size limits before performing uploads or processing large data set. So why it's neat, like if you have some file that is having more than 1 GB or 2 GB, if you read complete file, so it will take like think the file is 2 GB, right? So, and if you read that file, so it will store all the 2 GB data in the RAM, right? So this is not good. So that's why first we will check the file size using this one, and we will chunk that files, like we read 100 KB data, 200 KB data at once instead of loading 2 GB data. Calling OS remove or path unlink bypass the operating system recycling and trace completely. So the data is instantly unlinked from the file system and is extremely difficult to recover. So what it means, like you having some file, and if you remove using os.remove or path.unlink, that file will be removed completely from the system. Normally if you delete any file, right, so it will go to the trace or recycle bin first. After that, from there you can remove, right? and you can restore if you need it. But if you delete using this one, it cannot be restored because it will permanently delete. We have this, we will check this one, okay? So we have same VRM, we need to import OS, shutil for copy, path have import path. So we have original path test.txt, copied file test underscore backup.txt, and rename file report.txt. So we created these three variables, okay, with the current directory like path and this one. So target file paths. So with open original. So what is with open? We will see in the later video. You can use open also original. So it will take path of this file, write encoding UTF-8 and as a app. So it will open file and it will like we are using name as a app here. So we use app.write. Hello, this is the file system test script. Next, what we are doing? We are checking original.exist, right? This original. If we check this one, if it is exist, what it will do? It will take original and it will take copy, like this is source and this is destination, right? So it will create copy of that file. Okay. So we check here what we are using, copy to here. So what it will do? It will copy metadata also. So you can see print copied original to copied and metadata preserved. So what is the copied here? Test backup.txt and original test.txt. Next we have change file. Change file size, right? So rename.exist. We are checking the okay, rename this one. So copy.exist it is first we are checking like copy.ext is exist or not. If copy.rename exist, then it will copy and rename the file. Okay. Next it will check rename.exist. It is rename like it's exist or not. Again os.port get size, it will get the size of the file. Okay. And it will print the size OS and size Pathlib. So what it's taking size from both like OS and Pathlib. Next we are having removing. So you can see we are using try here original.unlinks. We are deleting the original file and rename.unlink. So it will safely deleted rename file also. If we any error will come like the file not error, so it will throw delete failed, right? So we run this one first, okay? So you can see first it will test.txt to test backup.txt. Renamed text.backup to file report, final report. Next it is printing the size. Safely deleted original test.txt and safely deleted rename final report.txt. So this is removing from here original.unlink and rename.unlink. Okay. So we make some changes here, like think we don't exist, we don't have the original file, right? So we created path here, path.txt and original path with open. So we will comment this code, okay? So we commented this one. Now what we are trying to do, we are trying to check here original.exist, then we are copying this one. Next we are checking copy.exist. Both are not exist. We are checking rename. So where we are copying renaming this one here. So that will also not exist, right? So if I run this one, what we will get? Delete failed. The system cannot find the file specified text because test file we are not created here. We are commented. So this code also will note. This will call. This will code also not get called, or this code also will not get called, right? So only it will come to here directly, and it will try to original.unlink. So it will try to delete that, and it will fail. So it will go here delete failed. Okay. And if I uncomment that, okay, and original copy, I created copy, but I ignore rename here. And if I run this one, so you can see rename test backup.txt is printing, right? Rename this one. But this code is not executable. I commented this one, so it will print renamed. But when you go to the delete, the system cannot find the specified file report, right? Because we are not renaming this one. So the original file rename will not be present. So this is the how we can create and rename and copy the file. Okay. So next we have here. So like I already told you, like we can use open directly without using the with keyword. Here we are using with, right? And we are using any opening file with dot open. Why we are using with? So we will be seeing that. So why? First, like if we are reading this file, we have this code. If I run this one, so data.txt, and we are reading, and we have content app.read. So we are reading this one. After that, we have some logic. You think we will get some error. So this I added for check only, like result we are doing 10 divided by 0. So what we will get? We will get 0 division by division error is raised here. Okay. So if I run this one, so we will get, first we will get no such file or directory data.txt here. Okay. So if I try here, copy this one. And we will create the data.txt. Okay. Data.txt. So it will open the file and it will read here. Okay. After that it will come here. Then it will get the error division by 0. Okay. So this will not be, the file will not be get closed. So the script sold immediately and app.close is never executed because the error thrown from here. So that's why this will not get exit. So this will create problem. Okay. If some other person try to read, then it will not work properly. So to resolve this error, we use with keyword. Okay. So we use with keyword, and after that, if we get this error also, right? Not this, like any error we get after that, then the file will automatically get closed. So with will handle this app.closure. Okay. So if your script crashes before reaching close, the file pointer remains logged and memory leaks, and other system process may block when trying to access the file. So what is this? The absolute gold standard is the with statement context manager. It guarantees that the file will safely get closed in the millisecond executions. Leave the code below unblocked. Code. Okay. So with data.txt encoding data.file reads print data. File is automatically closed here. No leaks was used. We are not manually calling here, right? Like close app.close or data.file.close. While reading and writing operations. So Python gives multiple ways to consume and write text stream. Choosing the wrong methods can run your server out of the RAM or corrupt your content. So what we have, file.read reads the entire file, single giant string. Okay. Read line, it will read line by lines. Reads the entire file and return the list of string, one per line. Read lines. Okay. So there will be difference. It will read complete in single string or object. It will line by line. and it will read line by line, but what it will return, it will list of strings. Okay, so the string will contain each item as a per line. Okay, so direct iteration best practice, iterating over the object itself, reads line by line lazily, holding only one line in RAM at a time. Okay, and if you use this one, then it will hold all the data in the RAM. So here you can see we are getting no such file or directory names.txt. Okay, so we'll see first in which directory we are. So I will check os.get cwd, right? Cwd. So you can see I'm inside C users. So if I do os.ch dir, again if I run this one, so we will be in this directory. So I need to move to the again and working with files. So I'm in this directory now. If I run this code, so I will get this file. So I have the names files in this directory. Okay, in the so what it is doing, it is opening the file names.txt and reading the full file. Okay, so when you check, it will printing Alice Smith Bob. Okay, so it is printing complete file here, but read line by line. Here check with f.read we are using. Again we are using with open names.txt r and line 1 f.read line and step f line 2 f.read line. So print first name and second name, line 1 and line 2. Okay, so if we check here, we have first name Alice Smith, second Bob Jones, third we have open with each log files log. So we have one more file called log files.log or as log. Okay, so for lines in logs, we are getting line from the log. Okay, if error in lines, line.strip memory footprint. So what it is doing, error database connection timeout and error. So it is printing line by line and it is reading from this one. We are not using read lines direct, we are opening with as a log and we are using for loop, right? So how this data is coming, because these files I having in this directory. So I have these log files. If I open this one, so you can see I have this data here. Okay, so what it is saying, if error in line, so it will stop here, like print line strip here. Okay, writing files. So this we are doing for how we can read files. Next we will learn about how we can write files. File.write string, write a single string block to the file, not that it does not append new line. What it means, when we have any file and we try to write, it will overwrite that. Okay, write lines attribute. Writing a list or tuple of strings sequentially, it also does not add automatically line break. Okay, so you can see we have with open output.txt, right? Python dot is amazing, right? Sorry, Python is amazing. Second, we are writing welcome to advanced IO. Next, what we are calling this one, and again, if I open this file, what I will get, output.txt here, output.txt. So Python is amazing. Welcome to the advanced. Okay, line append content and line another append content. From this is coming from this here, this one, right? Lines. Okay, line append. So you can see we are adding new line here, right? In all these things. If I remove this new line, if I run again, so you can see it's adding after from there, that is ended here, right? So it is not printing the new line. When you need for that, you need to use this new for new line, like it will move that cursor to the new line. So this is how you can write files. Okay, navigating the stream seek and tell. What is the seek and tell methods we have? Okay, so when we read file, so the file system move to the playhead pointer forward. Once you read the character, you cannot read it again unless you rewind the file stream. So what it means? So file.tell return the integer representing the current byte index position of the file pointer, and file.seek offset. Okay, move the file pointer by offset byte. The output whence parameter indicates absolute start with 0, current position, end of the line. So what it means? So first we read any file. So we read it like first line. After that, if we read again, it will move. We read it from the second file because the cursor moved to the second line. So for that, we need to reset using the seek. So how we can do that? So we have this seek method here. You can see we have stream.txt file. Here we have this character. Okay, so we are using with often stream.txt read starting pointer f.tell output 0. So it will tell the pointer character f.read 3. Okay, so what it will read 3 characters, so it will print ABC, and again we are checking f.tell. So what it will be 3. Okay, so is that string here 0 1 2 3. So it will be here. Again rewind the file string back to the absolute beginning. So we will f.c, we will be moving that pointer to the 0th position here again. So after rewinding pointer f.tell, so what it will tell? It will tell us like the pointer is on 0 because we are moved using C. Now jump to byte index position. Before we move this to the 0th position. Okay, if we read again this file like f.read, so it will be print again ABC because the current pointer is here on ABC. If you run again like 2 times, then it will be next time. But here what we are doing, we are f.c. So what it will do, it will move that pointer to the 4th position like here. So what it will print EFGH. Okay, f.read. So it's not printing complete syntax. So this is how the tell and seek we can use. Okay, so if I have this one, so string f12 f.character 3. Okay, if I copy this one and I move, we seek here 0, right? If I paste here and I read it again, I change this to 4 and 4, and if I again set this one 5 and char 5. Okay, here you can see I'm not setting seek 0, and if I copy this one after moving this to this one, and I will copy this, and after before that I will check this, right? So if I run this one, what it will do? So it will check, you can starting pointer 0, read character ABC, pointer index 3, right? Again here after 3, and we are set at 0 here, right? After that we have reading 3 again, so it will print ABC again. After that we have after rewind pointer 3. Okay, this after rewind pointer 3, so it will be 3 here because we, from 0 to 3 we again came to 3. It will print the character at 3. After that f.read again, So it will go to the next character. What is the next character? DEF. Okay. So this will print. So this will print here. After that, we are doing f.c. So it will continue, like it will print 0 and it will move the cursor to the fourth position. So this is how we can use tell, seek and tell to move the position of the pointer. So we can move starting, ending, middle, where we want to read. So this is the related to the encoding, like open with Unicode.txt read, and we are using this one. Okay. So this is theory related to this one, like ASCII character or this one. So I have this file here, and if I execute this one, so you can Unicode error on Unicode character coding cannot decode byte. Okay, and it will return this one f.read. It's critical bug pressing on Windows system with text content Unicode. So when we have file that contain Unicode character, so that will be failed. Okay. So similarly, we have for how we can work for binaries. Okay, binary data. So by appending B to your mode, RB or WB, the bypass encoding and decoding system completely and reads the data directly into your byte system object. So this is, you can see the code and you can try yourself. Now we have cheat sheet. Okay, so how the read text, read only. If we use W mode, write only. So type we have here text, right? And RB or WB is for binary data, matches the text most behavior. So here we have create file. Okay, if we directly use read, it will throw error if file that does not exist. It will not create file. Okay, truncate content no, and we use directly write. If we don't have any file, it will create. Append will also create. X raise error if exist. Okay, when it will throw error, it will throw error when the file is exist. No, not like file is not exist. When you use this one, it will throw error when file does not exist, right? So these are the related to the file input outputs. So how you can read, write, how you can move cursor. Okay, so please like and subscribe and share this video. If you have any doubt, please ask in the comment section. Thank you.